Not 10, I think module, the probability rules is what it is. So we talked about the addition and subtraction rule. This one is called, the last rule is called the conditional rule. And the conditional rule always has the word given, okay? It always has the word like given or something like that. It's what's the probability of this given that this has already happened? What's the probability of this based on this condition? The formula, I don't do formulas in this class, but I got to kind of talk about this for just a second, is that it's written like this, and this right here, this line right here means given. What this means is that you are probability you find A given that B's already happened. I'm coming up with the formula off the top of my head, but I believe it's this, and B divided by P and B. The thing that happens to me in my head right here is you only look you're like separating it out. So I'm only looking at B and then figuring out what's happening in there. And this will make more sense when we get to the table and all this. But I just wanted to write that formula just in case you see it anywhere. I don't think you will. When I said the probability is always what you're looking at divided by the total, this one's actually changing your total because it's telling you to focus only on this part right here. All right, so you got these bags 1 through 6, some white, some gray. What's the probability that the selected ball is white? Okay, so on this one, you're just doing white out of the total. So there's 2 white out of 6 total balls. All right, so your first conditional, what's the probability that the selected ball is white given that the ball is less than 5? Okay, so now what I'm looking at here is that it's white given the total amount that's less than 5. The total amount that's less than 5. So that's only 4. There's only 4 that are less than 5, right? 1, 2, 3, 4 are less than 5. So I've separated those out. Like I draw it out and I say, hey, this number is less than 5. You know you only have 4 options, 1, 2, 3, and 4. So now the white out of that would be 2. So what that does is you always separate, when it says given, you always separate that part out and only look at the total there. So it's based on that condition. So given that it's less than 5 tells me I only have 4 of them that I'm actually looking at, and then it's white out of those. So the 2 out of 4. All right, so when you have a two-way frequency table, what you do on this is you are going to, if it says given, you're going to focus on only that row or only that column. So here, a local high school has both male and female sports. Find the different probabilities. So a sport here, the probability of a sport would be, well, first of all, before I even start this, I'm going to go ahead and write these all out. There's 50 total, right? So 20, 30, 18, 32. Just to go ahead and get my totals amount here, okay? So the probability that it's you randomly pick someone and they play a sport is 32 out of 50. So that's just 32 out of 50. That's not really any different. The probability that they're male and play a sport would be 12 out of 50. Okay? That's nothing new. Nothing new on those. So male and sport. All right, so now the probability that I randomly pick someone and they're male given that they play a sport means, first of all, that I'm only looking at this column right here, okay? I only care about that column. I'm not even paying attention to this one. So I know that they play a sport. So now what's the probability that you pick a male out of the people that play a sport? And that is going to be 12 out of 32. Okay, so you see how it changes the total amount. If I know they play a sport, there's no reason to even look at the no sport people. So I'm only looking at the column that says sport, and then I pick the male out of the people that play sports. Okay, so that is what the conditional probability is where you are picking the probability based on a condition. So on like these tables right here, you only look at a certain row or a certain column. Let me see real quick. I want another version of this, but I got to see if I can generate one. This will work. All right, cats and dogs and vaccine or no vaccine. I'll probably try to make that a little bigger even. All right, first thing I always do is go ahead and get my total so I don't have to do that later. That's 40. It says 80 right here. That's 40 as well. That's 38, so this is 42. All right. So now going through the same steps, a vaccine would be all the vaccines, so that would be 40 out of 80. A probability of cat and vaccine would be 24 out of 80 still. I'm not changing my total amount. It's the cat vaccines out of the total amount. And then the last one here says probability that you randomly select a cat given, so remember this means given, and you focus on the vaccine. You always focus on the second one. Probability you randomly pick a person that has cat given that they have a vaccine. So if I know they have a vaccine, I am only looking at that row right there. I'm not even paying attention to the other ones. So a cat out of that row would be 24 out of 40. Okay? So I use that row for my answer on that one. I only look at that row, which is 40. So it's the cats out of there. If I already know they have a vaccine, then I'm just shooting the cats out of the vaccine ones. So whatever that second one is, you only look at that row or that column. I think the next one's pretty similar to that. Okay, sorry. All right, so you got male, freshman, sophomore, junior, senior, male, female. Yeah, okay. What's the probability that the student is male or junior? Okay, male or junior. So male would be these. Oh, man, I need to add these up real quick. It's going to be a little bit of a pain to add up, too. Let me get my calculator here. 37 plus 17 plus 21 plus 20 is 95. There are 224 total. That's 129. This is 68. Oh, that's 50. $50, 62, 44. Okay. So go back to this. What am I doing? Probability that's a male or a junior. So if I add up the males, that's 95. If I add up the juniors, that's 62. What's wrong with that number, though?
It has the females, and it's only asking for the males.
That's okay because it can be a male or a junior. So if a female is a junior, that's fine. That would still be true because they're a junior. So since it says or, when you see the word or, you always think add. So I add up the males and I add up the juniors. Okay? But what's wrong with what I added up there?
It's going one from the male juniors is added twice.
I added this number twice. Okay? I added it when I did the males and I added it when I did the juniors. So I'm going to subtract 21 from that. So 95 plus 62 minus 21 would be 136 out of the 224. Okay? So when you see or, you think add, and be careful of, I call it overlap. But you're adding that twice in, okay? So you got to subtract that back out. All right. Our new one. What is the probability that the student is a freshman? Freshman given that the student is female. So since it says given that they are female, I'm only looking at this row right here. Okay? Only look at female row. All right, so my total is going to be 129 because there's 129 females, but what's the probability you get a freshman out of those females? That would be 31. Okay, so I only look at, I guess you can't see that. 31 out of 129. So it's just like you separate the males and females out, you walk into the female room, there's only 129 people in there. So that's my new total amount. So whatever that part is after the given, make sure you paid, that's the only row or column that you're looking at. And then the last topic here, just kind of talking more about this a little bit, but same idea. I don't think anything really changes. So a group of 150. So what's that? 90. So that's 60. That's 96. So that's 54. All right. Find the probability that the patient showed improvement. So it doesn't, all we're caring about is the improvement. So that would just be 96 out of 150. Double check that. 96 divided by 150 is 0.64. Okay. All right. Next one we are doing find the probability that the patient showed improvement given that they took the new medication. So the new medication means I'm given that. I know they took the new medication, so I'm only choosing out of those 60. And then it says what? Showed improvement. So improvement would be this one right here. So that would be 39 out of 60. Double check that. 39 divided by 60 is 0.65. All right. Is there evidence that a patient who takes the new medicine is more likely to show improvement than the chosen patient from the group? No, not really, because they're about the same. All right. So if there were a big difference, like if you saw a big difference on this one, then yeah, they could show improvement. So that one's just like what this is used for. Everybody, basically what this is saying is when you look at just the improved people, like the improved people over the whole group, they improved by about 64% of them improved. Well, if I just do the new medication, it's about 65%. So that new medication doesn't change that much of the improvement. If those numbers were different, then they would. I wanted to skim through those real quick and see if I got. So like this one right here, if they took the class and failed the test, so to pass would be, the probability they passed is 44%. The probability they passed given they took the class was 70%. So yeah, if they took the class, they had a lot better chance of passing the test, right? So that kind of makes sense when you look at those, just to see the different ones there.